Welcome to Oryx Learning. Today's lesson is going to be on Unit 1, Real Numbers, Lesson 7, Computing with Scientific Notation. Imagine that there are 130 billion spam emails sent every day worldwide. If there are 365 days in a year, how many spam emails are sent every year? This number is too big for your calculator to handle, so is there another way that we could solve? This lesson in scientific notation focus on that way to solve. We will revisit this problem at the end. You can use the product of powers and quotient of powers properties to multiply and divide numbers written in scientific notation. For example, 7.5 times 10 squared times 2.5 times 10 to the fourth. In order to start this, we can rewrite the problem using the commutative and associative properties, making it 7.5 times 2.5 times 10 squared times 10 to the fourth. Multiplying, we get 18.75 times 10 to the sixth. Remember, when multiplying like bases, we add the exponents. In this case, 2 plus 4 would give us the 6. This answer is not in proper scientific notation. In order to put it in scientific notation, I will move the decimal point to the left and add 1 to the exponent. When adding or subtracting decimals in standard form, it is necessary to line up the place values. In scientific notation, the place value is represented by the exponent. Before adding or subtracting, both numbers must be expressed in the same form. So for example, 8.25 times 10 to the fourth plus 7.45 times 10 to the fifth. First, we need to make the exponents the same, so we can rewrite to ensure that they have the same powers of 10. In this case, 8.25 times 10 to the fourth became 0.825 times 10 to the fifth. Now that the powers are the same, add or subtract the numbers in front. 0.825 plus 7.45 will give us a value of 8.275. So 8.275 times 10 to the fifth will be our final answer. Our first example, evaluate 4.641 plus 25.67. Lining up the decimals and adding them together, we will get a total of 30.311. Make sure when you line the decimals up, you line them up with the decimal vertically in place. Next, we'll evaluate 14.67 minus 2.3. And remember, when adding or subtracting decimals, line the decimal places up vertically and add or subtract the given values. Be sure to keep the decimal place in line for your answer as well. So 14.67 minus 2.3 should result in 12.37. Evaluate the expression 5 to the seventh over 5 to the fourth. Using our quotient property, dividing like bases, we will subtract the exponents. 7 minus 4 is 3. 5 to the third is a factor of 5 used 3 times. 5 times 5 times 5, which will give us our final answer of 125. Evaluate the expression 5 to the fourth times 5 squared. Like base multiplication, we'll use our product rule to add the exponents. 4 plus 2 is 6. 5 to the sixth is that factor of 5 used 6 times, multiplied together to get 15,625. Next, we will evaluate 2.75 times 10 to the fourth times 1.5 times 10 squared. I'm going to give the answer in scientific notation. So as shown in the example, we will first rewrite the problem using our commutative and associative properties to make it 2.75 times 1.5 times 10 to the fourth times 10 squared. Multiplying the values out, we will get 4.125 times 10 to the 4 plus 2, or 10 to the 6th. This value is in scientific notation, so our final answer is 4.125 times 10 to the 6th. Evaluate 4.2 times 10 to the 6th divided by 2.1 times 10 squared. Give the answer in scientific notation. So again, we will rewrite these problems using the commutative and associative properties. 4.2 divided by 2.1 times 10 to the 6th divided by 10 squared. Dividing the values, 4.2 divided by 2.1 will result in 2. 10 to the 6th divided by 10 squared, our quotient property states that we will subtract the exponents, and 6 minus 2 is 4. So 2 times 10 to the 4th is in scientific notation, so that becomes our final answer. Evaluate 2.75 times 10 to the 4th plus 1.5 times 10 squared. Give your answer in scientific notation. Remember, when adding two numbers in scientific notation, you first need to write the numbers so that they have the same power of 10. So in this case, we will make 1.5 times 10 squared 0.015 times 10 to the 4th. That way their powers of 10 are the same. We will then rewrite the problem using our commutative and associative properties, making it 2.75 plus 0.015 times 10 to the 4th. Adding the values together, our final answer will be 2.765 times 10 to the 4th. Evaluate 3.56 times 10 to the 5th minus 1.23 times 10 to the 4th. Give the answer in scientific notation. For this problem, we will change 1.23 times 10 to the 4th to 0.123 times 10 to the 5th. That way, our powers of 10 are the same. Rewriting the problem with our commutative and associative properties, we have 3.56 minus 0.123 times 10 to the 5th. Subtracting the values, we'll get our final answer of 3.437 times 10 to the 5th. How many particles measuring 7.5 times 10 to the negative 6 meters can fit in a span of 3 meters? Write the answer in scientific notation. The equation is 3 times 10 to the 0 divided by 7.5 times 10 to the negative 6. Dividing the numbers out and rewriting, we'll get 3 divided by 7.5 times 10 to the 0 minus a negative 6. Remember, quotient property, like base division, subtract the exponents. 0 minus a negative 6 is the same as 0 plus 6, or 6. So 3 divided by 7.5 is 0.4 times 10 to the 6. In order to write the number in scientific notation, I will multiply the 4 by 10 to the negative 1st, equivalent to 0.4. And my final answer will be 4 times 10 to the 5th, adding 6 and negative 1 together. So back to our spam question. If there's 130 billion spam emails sent every day, and there's 365 days in a year, how many spam emails are sent every year? So we can make that problem 1.30 times 10 to the 11th to represent the 130 billion. 365 would be 3.65 times 10 squared. Multiply those values together and we'll get 4.745 times 10 to the 13th, which is equivalent to 47 trillion 450 billion emails per year, spam emails per year. In review, you can use the product of powers and quotient of powers properties to multiply and divide numbers written in scientific notation. When adding or subtracting decimals in standard form, it's necessary to line up the place values. In scientific notation, the place values are represented by the exponent. Before adding or subtracting, both numbers must be expressed in the same form. That is our lesson on Lesson 7, Computing with Scientific Notation. Thank you for joining us.